Guys, so before we get started today, are there any questions over the homework assignments? Questions over the homework? Anything we've done so far? What we're talking about today is adding and subtracting matrices. What we're going to start off with is adding and subtracting matrices. Now, to add or subtract two matrices with the same dimensions, add or subtract the corresponding elements. The numbers that are in the same spot, we're going to add or subtract. The sum or difference of two matrices with different dimensions is undefined. If the dimensions are not the same, we cannot add or subtract. Okay, so if we look at this here, our first matrice, what are the dimensions of it? 2 by 2, yes? The second matrice, what is its dimensions? Are the dimensions the same? Yes. So that means we can add these, and we're going to add the corresponding elements. So if we look at the first matrice, the top left element is 2. And we're going to add to it the corresponding element. So in the top left would be 1. Top right is -1, and its corresponding element would be 2. Bottom left of our first is 3, and its corresponding element is 4. Last one would be 0 and -2. Since we do have the same dimensions, we're going to add the corresponding elements. Okay. Now, I did put 2 of them on the same page to save a little room. So if we look at this here, 2 plus 1 is? -1 plus 2 is? 3 plus 4? 7. 0 plus -2? That's it. Questions on this here? Let's look at the next one. Dimensions of the first one is a 3 by 2, because we go rows by column. So we have 3 rows, 2 columns. We go down 3 over 2, so it is a 3 by 2. The second one is a 3 by 2, yes? No, you're good. 3 by 2. The way I keep track of the dimensions, I always start in the top left corner and count down, then over. So 3 down, 2 over, it is a 3 by 2. They are both 3 by 2s. So that means we can indeed subtract them. So we'll have 2 minus -1. So 2 minus -1. Then we'll have 3 minus, -3 minus 2. Then we'd have 5 minus 4 minus -2 minus 8 minus now at this point here we just need to subtract, simplify our terms. So 2 minus -1, because our negative and negative make a plus. 2 minus -1, the negative and negative make a plus, giving us 2 plus 1, which is 3. -3 minus -3 minus 2. -5. 5 minus 7. -2. 4 minus 8 is indeed -4. -2 minus -5. Negative and negative make a plus. 3. 8 minus 6. And that's it. Questions on these here? We ready for the next one? All right. So let's just go on and do this here. So we'd have -8 plus 6 first, yes? Then 1 plus -1. And then 3 plus So what are the dimensions? 2 by 3 and a 2 by 2, yes? To add or subtract, the dimensions have to be the same, yes? Not possible. Because the sum of difference of two matrices with difference dimensions is undefined, so we'll say undefined or not possible. We just can't do it. Because the dimensions have to be the same. Because even if we try to add 0, 3 plus 0, we're changing the dimensions of that second matrix. We're adding something to it. So we're not actually adding these two. We would have to change the second one to be able to do it. Not possible. Here we have a 2 by 2 and a 2 by 2. So the first thing we would do is negative 1 plus 6, 7 plus negative 4, 5 plus, and 3 plus. Negative 1 plus 6 is 5. 7 plus negative 4, 5 plus negative 8, and 3 plus 2. That's it. Questions on this here? Questions on anything we've done so far? Two minus negative 3. Because 2 minus negative 3 would be the same as 2 plus 3, which gives us 5. 5 minus 0.
Same thing. It's like 4 subtract 3 subtract 4.
No. No, could it be? Technically, it's not the same, but it's okay. I'm gonna say unless there's some weird thing it shouldn't.
Because what are our dimensions?
We can't.
2
1 and 1
2 by 1 and a 1 by 2. Not possible.
Yeah.
Because the dimensions have to be the exact same. Because the first one's 2 rows and 1 column. The second one is 1 row and 2 columns. They're not the same dimensions.
Jacob, I love how you're bashing her because it's the one that says subtract first.
Do we feel comfortable with these here? These two aren't on there because I felt at this point we were comfortable with this.
Yeah.
So we can move on. Now, we could have done these in the calculator because we could have gone over second matrices. So that the first one's a 2 by 2, and we'll just leave it there. Second matrix, we'll say the second one's, make it also a 2 by 2. And we can say second matrix A plus second matrix. All we're doing is that I define the two matrices and recall them like we did for our REF. A plus B.
That's why I'm so confused.
Now, if we look at the previous one, not that one, this one. If we were to type it in, we'd go second matrix over to matrix A and say edit. This one here is a 2 by 1. And it is 2, 5. Second quit, second matrix. Now this time, since we have two different matrices we want to type in and work with, we'll set the second one as matrix B. It is also a 2 by 1. It is negative 3, 0. Second quit. Now we want to take matrix A because that's the first one that we have, our 2, 5. And we want to subtract from it matrix B. And we get 5, 5. Yes? So it works out. It will do it for us. You're not really saving much time with adding and subtracting matrices. We can almost write it out and do it faster than we can type it in. Scalar multiplication is our next bit. So when we scale something, we either make it bigger or make it smaller. Because scale models are a scaled down version of whatever the model is. So to scale something, we take whatever the scalar is and multiply it by each element in the matrix. So if we look at this here, the scale for this here is 2. So we're going to be scaling all this up by a factor of 2. So for us here, it means that every element in this matrix is going to be multiplied by 2. So we're going to say 2 times 3 and 2 times negative 2 and 2 times 1 and 2 times 5 and 2 times 2 and 2 times 0. So we're going to multiply every element in that matrix by 2. And indeed, 2 times 3 is 2 times negative 2, 4. 2 times 1 is 2. 2 times 5 is 10. 2 times 2 is 4. And 2 times 0 is 0. Questions on scalar so far? We feel comfortable with scalars. I don't think we need to talk too much more about that. Because all we do is take whatever that number is in front and multiply it through, yes? We can do addition, subtraction, and scalars together. So if we look at this here, the first thing we want to do when having more scalars and addition, subtraction is to work with the scalars first. So this first matrix, since it's being multiplied by this scalar of negative 3, we're going to multiply the negative 3 first. So negative 3 times 5, negative 3 times 0, negative 3 times negative 2, and negative 3 times 4. So we're going to distribute that negative 3 through. Now, negative 3 times 5, 13. Negative 3 times 0 is 0. Negative 3 times negative 2 is 6. And negative 3 times 4? Yes, negative 12. Now, the other one's going to stay negative 1732. Once we get the scalars done, then we can move on to our addition. So we'd have negative 15 plus negative 1, 0 plus 7, 6 plus 3, and negative 12 plus 2. Because the sign in the middle is just plus. And the negative 3 was just in front of the first matrix, it wasn't in front of the second. Now, the only way we would multiply it with both is if it was negative 3 parentheses, then our two matrices being added together. Because we're saying it's being distributed across both. Negative 15 plus negative 1 is negative 16. 0 plus 7. 6 plus 3. Negative 12 plus 2. Negative 10. And that's it. Bless you. Questions on this here? Now this one here, especially when we get a lot of these scalar multiplications and the addition subtraction put together, the calculator starts becoming a little quicker. Because if we look at this here, we're going to go second matrix over to edit. And we'll put enter to click the first matrix. Now here it is a 2 by 2. And we have 5, 0, negative 2, 4. We type each number in and hit enter. And once we get it typed in, we're going to go second quit. Second matrix over to edit. And for our second matrix, B, we'll say it's a 2 by 2. -1, 7, 3, 2. Second quit. Now, let's go back here. Now we plug this in as matrix A and this as matrix B. And we applied a -3, a scalar of -3 to the first matrix, yes? So we type it into the calculator. We're going to say -3, second matrix A. We can put them right next to each other because the calculator is going to understand they're being multiplied, they're being scaled. And to that, we're going to add second matrix B. Did we get the same answer? So when we start doing multiple scalars and multiple addition subtraction, this can be helpful. Questions on this here? We can look at number 5. So here we're multiplying through by -7, yes? So we could write it out, say -7 times 2, -7 times 3, -7 times -2, -7 times -7, -7 times 4, -7 times 7, -7 times -2, -7 times 5, and lastly, times -6. And we multiply this out, we get -14, -21, 14, 49, -28, -49, 14, -35, 42. Questions on number 5? We're ready to look at number 6. Four. We have a scalar of 4. We'll have to deal with it first. So we're going to multiply that 4 through. Now, it doesn't have a number written here. But if we said we had -2 times this matrix E here, with that 2, that scalar and that minus, you can do one of two things. You can either multiply through by the scalar of 2 and then subtract our two matrices, or multiply through with the -2 and then add. Because if we multiply the 2 through, we'd still have the negative here. So it'd give us 2 times 9, 2 times 7, 2 times -6, 2 times 5, 2 times 2, 2 times -3. And that's fine. We would then subtract the two matrices and go from there. However, we could multiply through by -2, but if we do, that negative we were subtracting with has now been put into the matrices, so we're going to add the corresponding solutions. Do we kind of see how that works? So if there's a matrix, there's a scalar with a negative in front of it, and we're going to, so like this here, if it had been -2, we can either take the negative and the 2 and multiply through the second. If we do that, we will add the matrices. We essentially took that negative inside the second one, so we'll add the result. Or instead of multiplying through with the negative, we just multiply the 2. The negative still stays between the 2, and we subtract. Does that make sense? So if you take the negative into that matrix, we're going to add the results. If you don't, we subtract them. That's the only difference. But here there is no 2. We can just leave it as this here. Now we will multiply. So 4 times 3 is 12. 4 times 5 is 20. 16, 8, 0, negative 8. Now, because they are the same dimensions, we can subtract. minus 9, 20 minus 7, 16 minus negative 6, 8 minus 5, 0 minus 2, and negative 8 minus 3. Well, 12 minus 9 is indeed 3, and 13. Negative 11. Yeah. Yeah, because our negative, so 16 minus negative 6 would be 16 plus 6. 8 minus 5 would be 3. 0 minus 2 would be negative 2. And negative 8 minus 3 would be negative 11. Because for 8, 2 would give us the 10, and then we have one more. Questions on this here? We're ready for the next piece. Four through 8. So you're going to do problems 4 through 8. So 4, 5, and 6. Perform the indicated operation if possible. So add or subtract. 7 and 8. Describe and correct the error. So there's an error on both of those. Describe it and then fix it. 9 through 21 odd. So 9, 11, 13, 15. Just perform the operations. Use scalar multiplication or scalar multiplication, addition, subtraction to find the result. 17, 19, and 21. It tells you there what the matrices A, B, and C are. So for like 18, B minus C, you would subtract matrices B and C. So just fill in what A, B, and C are and find the result.